Formulation of LPP. The formulation of LPP is an important concept in obtaining an optimum solution to the given problem. The following are the steps. It consists of mainly three steps. One is identifying the decision variables of the given problem, and second one is identify the objective function, and here itself decide the nature of the objective function to the given problem. Either it is maximization or minimization. And in the step 3, identify the available constraints. Express them as equalities or inequalities. Okay. So let me solve a smallest LPP problem. Okay. Here a company has 3 operational departments. One is weaving, processing and packing, with capacity to produce 3 different types of cloths. A company has 3 operational departments: weaving, processing and packing, with capacity to produce 3 different types of cloths, namely suiting and shirtings and woolens. It produces 3 different types of cloths. One is shooting, shirting and woolens, by resulting a profit of rupees 243 per meter respectively. 1 meter of shirting requires 3 minutes in weaving, 2 minutes in processing and 1 minute in packing. Similarly, 1 meter of shirting requires 4 minutes in weaving, 1 minute in processing and 3 minutes in packing. 1 meter of woolen requires 3 minutes in each department. In a week, total run time of each department is 60, 40, 80 hours for weaving, processing and packing respectively. Formulate the LPP to maximize the profit. Formulate the LPP to maximize the profit. Okay, this is your problem. To solve this one, first we construct. It has been given that it consists of 3 departments. Okay, departments are to be noted here, and it consists of 3 types of products are produced. So what are the products produced here are to be noted here. One is suiting, let it be X1. Second one is shirting, let it be X2. Third one is woolens, that is X3. Here we are having 3 departments. One is weaving, second one is processing, third one is packing. Okay, so these are the basic things which are given in our problem. See here, a company has 3 operational departments: weaving, processing and packing. Okay, and it produces 3 types of cloths. One is suiting, shirting and woolens. And also it results a profit are to be noted here. It results a profit of rupees 2, 4 and 3. Profits are to be noted here. It results a profit of rupees 2, 4, 3 per meter respectively. So while producing a meter of suiting cloth, it produces 2 rupees profit. Producing shirting cloth of meter produces 4 rupees profit. Producing a woolen cloth of per meter gives 3 rupees profit. So to produce this one, to produce 1 meter of shirting requires 3 minutes in weaving. To produce a 1 meter cloth of 1 meter cloth of suiting, 1 meter cloth of suiting requires 3 minutes in weaving. 3 minutes in weaving, 2 minutes in processing and 1 minute in packing. To produce 1 meter of shirting cloth, it requires 4 minutes in weaving, 1 minute in processing and 3 minutes in packing. To produce 1 meter of woolen cloth, it requires to be processed in weaving department for 3 minutes, processing department for 3 minutes, packing for 3 minutes. Okay, In a week total runtime, each department is having 60-40 hours of weaving. So availability of runtime or machine time per week is also given, that is to be noted here, which is given in hours. So here it is 60 hours. For processing it is 40 hours, and for packing it is 80 hours. Okay, so for the department weaving, here it is having 60 hours. For the department processing it is having 40 hours. For the department packing it is having 8 hours. We have to formulate the LPP. We have to formulate the LPP now. With the help of all these things, here it has been given 2 rupees profit, 4 rupees profit, and 3 rupees profit. Profit is given. So to maximize profit, we sell 3 different cloths. Let x1 is equal to 1 meter of suiting cloth, x2 is equal to 1 meter of shirting cloth, x3 is equal to 1 meter of woolen cloth. Okay, so from these constraints, now see here, from these constraints the available hours are given as, for the department of weaving is 60 hours. We can write this one as 60 into 60. For 1 hour it is having 60 minutes, which is equal to 3600 minutes, and this can be written as 40 into 60, that is 2400 minutes. And for this one 80 into 60, 8 6 are 48, 4800 minutes. Okay, now directly we formulate for weaving 3x1 plus 4x2 plus 3x3 less than or equal to 3600. For processing department, 2x1 plus x2 plus 3x3 less than or equal to 2400. For packing department, x1 plus 3x2 plus 3x2 less than or equal to 4800. How it is formulated and why it is formulated as like this? Here it has been given that to produce a suiting cloth, it should be in the weaving department for 3 minutes. So we are converted the hours into minutes. Okay, right? So here in the weaving department, suiting cloth is also produced, shirting cloth is also produced, woolen cloth is also produced. All these 3 cloths should be produced within the available time, and that is 3x1 plus 4x2 plus 3x3 less than or equal to 3600. Okay, next one. Here in the processing department, 3 different cloths can be produced and the available time is 2400. Then 2x1 plus 1x2 plus 3x3, which is less than or equal to 2400. That means the processing department should produce 2x1 products, 1x2 product and 3x3 products within the given time, that is 2400. And the packing department can also be produce 1x1 product and 3x2 products and 3x3 products within the given time, and these 3 are called as the constraints. We have constructed the constraints. Okay, now let we construct our objective function. our objective function is maximization of profit. Maximization of Z is equal to maximization of profit. Here profit is given as, by selling 1 meter of suiting cloth we get 2 rupees of profit. Then it can be written as 2x1 plus 1 meter of x2, that is shedding cloth, will gives you 4 rupees of profit. 4x2 plus, by selling 1 meter of woolen cloth, it will produce or gives you 3 rupees of profit, that is x3. So this is your objective function. Then finally the LPP problem is maximization of Z is equal to 2x1 plus 4x2 plus 3x3 subject to two constraints, 3x1 plus 4x2 plus 3x3 less than or equal to 3600, 2x1 plus x2 plus 3x3 less than or equal to 2400, x1 plus 3x2 plus 3x3 less than or equal to 4800 for all x1 comma x2 comma x3 greater than or equal to 0, and this is the way of formulating the LPP problem. Thank you.